Okay, so now we're looking at points on lines and plots of linear equations. So if I gave you an equation y equals 2x plus 1, this is the equation of a line. And you don't need to know what the equation of a line is at this stage. You'll do that in year 10. You just need to know that I'm telling you this is the equation of a line. So that's all that the significance of that is. This equation tells me what the y value is for any given x value. Just as we previously saw with the cost of mangoes and the income made with new members, it's just a formula where I put a value for x into the equation and it tells me what the y is, regardless of what it's representing. So for any x number that I chuck in here, I can figure out what the y is equal to. Here's an example. If a taxi costs $1, which we know as the flagfall, the moment you get in, and then it charges you $2 for every kilometers you travel, this could be written as 2 lots of the kilometers, so $2 per kilometer, plus 1, which was the flagfall. And the dollar sign is just representing the fee. So from this we could see that if the kilometers here was 0, we would still pay $1, which we know from the flagfall. If we traveled 1 kilometer, it would be $2 times the 1 kilometer plus the $1, so it would cost us $3. I could write the exact same situation as y equals 2x plus 1, where I've denoted y as the cost over here and x as the kilometers traveled. From the equation, how much would I pay if I got into the cab but realized I could just walk and got back out again? I would just pay the flagfall, $1. What about if I got in the cab and traveled 2 kilometers? Well, the equation here tells me that it costs me $1 no matter what I do. If I travel 2 kilometers, which is my x value, 2 lots of 2 is 4, plus 1, so I would pay $5. What about if I made a table of taxi fares with kilometers? So if I want to know what does it cost to use a taxi for certain distances, and I could plot it out on a table, it would look something like this, where I can see the kilometers across the top and I can see the fare cost along the bottom. So if I traveled 0 kilometers, I got in and then changed my mind, it's still going to cost me $1. If I traveled 2 kilometers, it would cost me $5, which we knew from before, and we can look at all the other values. So I could work out what it would cost if I traveled 5, 6, 7 kilometers and so on. So now I want you to do a couple of questions. So for each of these equations, you are to construct a table of values, which I've made for you. I just need you to put the y values in. And it said that it wants you to use -3 to 3. So that's why we've got -3, and it just runs all the way up to +3 on this side. So I'm going to show you an example of how to do the first one, and then this is one of the questions that I want you to do for this section. On the next page, I've put a graph up, and I want you to plot this. So just like we've seen before, we've got our x and y axis. You just find the point where x is -3, and then join that to the value y equals whatever we've put in the table. So let's look at the first one. If x is -3, and my equation here tells me that y is equal to x. So if x is -3, y is -3. If x is -2, y is -2. And so on and so forth. And you can see the pattern there. If I just skip down a few and look at this one here, then it tells me that the y value is 2 minus whatever the x value is. So if I look at the first one, -3, it would be 2 minus -3. So I could write that as 2 minus -3, and then a minus and a minus gives me a plus, so that actually becomes 2 plus 3, which gives me 5. If I skip across a little bit and look at, say, 1, I've got 2 minus 1, just gives me 1. So you see the idea. Whatever we're doing in the equation, which is the thing here, we just substitute in the x term, plug that in here, and it tells us what the y value is. With this example, same thing. If I have -3, I replace x with -3, and it'll give me the solution. So this is the graph that I've provided, and I want you to plot your points. So if you look at each individual point, let's say the top one, we've got minus 3, 3, minus 2, 2, so the x and y's are the same, from minus 3 to 3. So if we then go forward again, I would have, this is my minus 3 value for x, and it equaled minus 3. So this is my point, and that would be minus 3, 3. Now my next point, I go across to where x is minus 2, and I find y minus 2. So now if I join those up, it should be right there. And that is minus 2, minus 2. And you can see the pattern. If I did minus 1, that gives me this point. 0, 0, we're going to end up with 1, 1, 2, 2, 3, 3. So I can see from this that it's given me a straight line. So if I attempted to join this with a ruler, for example, and combine all of those lines, you can see that it gives me a straight line. And a straight line, which I now know is a linear relationship, linear straight line, tells me that the table of data that I plotted was linear in nature. It was linear data. So that's what I want you to do for all of the tables on the previous page. Just plot them all on this one graph here. So right at the end of this, we're going to do an investigation, and it's called the cup snake investigation, and it's all about stacking cups on top of each other. So if I had a polystyrene or paper cup, and I don't know how tall it is, for example, but what if I told you that I had another cup sitting inside it, and I could tell you how tall that was combined? Then we're going to look at, if I tell you that a cup is, sorry that's a bad cup, say 20 centimeters tall, big cup. If I add another cup, how much does it add? Well, say it adds only 2 centimeters. Then if I add another cup, how tall is it? And so on and so forth. So you can see if we add lots and lots of cups over time, we're starting to create that snake effect. And I've got a video that I'll link to this of people making cup snakes. So what we're going to do is we're going to try and figure out how tall is, say, a person in cups. You know, what about a building? How tall is a building in cups? And we're going to construct a relationship. So if I know that I start with 20 centimeters and every cup adds 2 centimeters, I can work out some sort of a relationship where I have, if I have one cup, that's 20, 2 cups is equal to 20 plus 2, 3 cups is equal to 20 plus 4, I can start to work out, I can construct a table, and I can try and figure out what the equation might be for the cups. And I can use this equation to figure out how tall a person might be, how tall a building might be, you know, and I can work backwards and say, well, how tall would 500 cups be? You know, and if I say y is the height of the cup, it would equal to 20, let's just say this is what it was, plus 2x, for example. Say that's our equation. This is the height of my cup snake. This is how many cups. And I can work backwards. If I know how many cups, I can say how high it is. But if I know how high it is, I could also work out how many cups. So that's something that we're going to look at in this task.
Flawless victory.